Internet of Things ESP32-CAM surveillance camera. The ESP32-CAM MB is a development board based on the ESP32 microcontroller, specifically designed for applications that require camera functionality. Here's a breakdown of its purpose and how it works. Purpose: image capture and processing. The ESP32-CAM MB is primarily used for capturing images and video, making it suitable for applications like surveillance, remote monitoring, and image processing projects. IoT applications: it can be used in various Internet of Things or IoT projects where the captured images or video can be transmitted over Wi-Fi to a server or another device. Prototyping: the board is ideal for rapid prototyping, allowing developers to quickly build and test their ideas involving camera functionality. How it works: microcontroller. At its core, the ESP32 microcontroller provides Wi-Fi and Bluetooth connectivity, along with sufficient processing power to handle camera operations. Camera module. The board typically includes an OV2640 camera module which can capture high-quality images and video. This interfaces with ESP32 using the I2C protocol. Programming: the ESP32-CAM MB can be programmed using the Arduino IDE or the ESP-IDF framework. Developers write code to control the camera, manage Wi-Fi connections, and handle image processing tasks. Power supply: the board can be powered via USB or external power sources, making it versatile for different applications. Data transmission: after capturing images or video, the board can transmit the data over Wi-Fi to a web server, allowing for remote access and control. Storage: it often includes support for SD cards, enabling storage or captured media for later retrieval. The FTDI-232 is a USB to serial converter chip manufactured by FTDI, or Future Technology Devices International. It allows communication between a USB port and a serial device such as microcontrollers, sensors, or other serial peripherals. Here's how it works and its main purposes. How it works: USB interface. The FTDI-232 connects to a USB port on a computer or host device. It handles the USB protocol, converting USB signals into a format that can be understood by serial devices. Serial communication. On the other side, it communicates using standard serial protocols such as RS-232 or TTL serial. This means it can connect to devices that use these communication standards. Driver support. The chip requires specific drivers to function correctly on the host system. Once installed, it appears as a virtual COM port, allowing applications to communicate with serial devices using standard programming interfaces. Data handling. It manages data flow control, baud rates, and can handle both asynchronous and synchronous communications. The chip also supports various features like hardware flow control and the ability to handle different data formats. FTDI-232 Purpose: communication. The primary purpose of the FTDI-232 is to facilitate communication between computers or other USB ports and serial devices, making it easier to interface modern computers with older or simpler devices. Prototyping. It's widely used in prototyping and development environments, particularly with microcontrollers like Arduino or Raspberry Pi, where, where serial communication is needed for programming or debugging. Embedded systems. Engineers often use FTDI232 in embedded systems to enable USB connectivity for devices that traditionally use serial communication. Debugging. It provides a simple way to send and receive data for debugging purposes, allowing developers to monitor outputs from microcontrollers and other devices. Overall, the FTDI232 is a versatile and widely used component for bridging USB and serial communication, making it essential in many electronic projects and applications. A 2 GB micro SD card is a small removable storage device used primarily in portable electronics. Here's how it works and its purpose. How it works. Storage capacity. The card has a storage capacity of 2 GB, which allows it to hold various types of data, such as photos, music, videos, and documents. File system. It uses a file system like FAT32 to organize data, making it easier for devices to read and write files. Data transfer. Data can be transferred to and from the card using devices with a compatible microSD slot, such as smartphones, tablets, cameras, and laptops. Speed class. The card may have a speed class rating like class 2, class 4, etc., indicating its read and write speeds, which can affect performance, especially for video recording or running applications. The purpose, storage expansion. It provides additional storage for devices with limited internal memory, allowing users to store more files. Portability. Its small size makes it easy to carry and transfer data between devices. Versatility. Commonly used in smartphones, tablets, cameras, and gaming devices, it supports a variety of applications from media storage to app data. Overall, a 2 GB microSD card serves as a convenient and portable solution for expanding storage in various electronic devices. Jumper wires. Female to female jumper wires. Both ends have female connectors used to connect components with male pins. Jumper wires are electrical connectors used to establish temporary or semi-permanent connections between components on a breadboard or other circuitry. They are essential in prototyping, testing, and experimenting with electronic circuits. Purpose of jumper wires. Connecting components. Jumper wires allows you to connect various electronic components like resistor, capacitors, LEDs, and microcontrollers without soldering. Flexible layout. They enable flexible circuit layouts, making it easy to change or modify connections as needed. Prototyping. Jumper wires are crucial for quickly assembling and testing prototype circuits, especially on breadboards. Debugging. They are helpful in debugging circuits by providing quick connections and easy alterations. How jumper wires work. Electrical path. They serve as conductors to create an electrical path between 2 points in a circuit, allowing current to flow between them. Insert and connect. On a breadboard, you insert the ends of jumper wires into the holes to establish connections between different rows or components. Changing layout. Since they are not permanent, you can easily pull them out or move them to create new paths or rearrange your circuit without damaging components. In summary, jumper wires exemplify the process of building and modifying electronic circuits, providing flexibility and ease of use in connecting various parts without soldering. An Arduino USB cable is used to connect an Arduino board to a computer or power source. It plays a critical role in both communication and power delivery between the Arduino board and a computer. Purpose of the Arduino USB cable. Power supply. It provides power to the Arduino board, especially when connected to a computer or a USB power adapter. The cable allows the Arduino to run its programs or interact with sensors and other components without needing a separate power source. Programming. The USB cable is used to upload code sketches from the Arduino Integrated Development Environment or IDE on a computer to the Arduino board. This is crucial during the development phase when you need to test and modify your code frequently. Serial communication. The USB cable facilitates serial communication between the Arduino and the computer. This means you can send and receive data to and from the Arduino using the serial monitor tool in the Arduino IDE, which is helpful for debugging or logging sensor data. How the Arduino USB cable works? Power delivery. When plugged into the computer's USB port, the cable delivers a regulated 5 volts power to the Arduino board. This allows the board to operate without an external power source, especially during programming or testing phases. Data transmission. The USB cable has data lines usually called D plus and D negative that carry information between the Arduino board and the computer. The onboard USB to serial converter, such as the Atmega 16U2 on many Arduino models, translates the USB signals into serial signals that the Arduino's microcontroller can understand. Bootloader activation. When the USB cable is connected and code is being uploaded, the Arduino's bootloader, a small program on the board, allows the microcontroller to receive and store the new program. Serial communication for debugging. Using the Arduino's IDE serial monitor, the USB connection enables you to send and receive text data, which is particularly helpful for debugging code or monitoring sensor output. That's all. Thank you.